Welcome to my presentation about AI application and electronic warfare operations. So, who am I and why should you listen to me? I am the head of AI for electronic warfare since about 2 years. I have worked 23 years within the electronic warfare domain. I've been coding since I was 11 years old, and I have developed signal processing software for several electronic warfare systems. And I wrote the interleaver for the Tornado. It's difficult for the most of you in here to understand what that is, but it's very cool, I promise. After I had this presentation, some of those pictures in Rome last week, a pilot came down to me and said, "Thank you for the interleaver, it is so good." So, quite nice to get. No one at Saab has ever said something like that. Lessons learned during doing that was that it is very difficult to create an electronic warfare system that works well, but it's pretty easy to make it one that works okay. When writing it, I realized that what I want to achieve is pattern recognition, and it's so difficult to achieve good pattern recognition within rule-based code. So when I joined the AI hype around 10 years ago, I realized that this was the way we should write such a interleaver and identification procedure. That's the way it should have been done from the beginning. And that's what we are working with now. And within the field of electronic warfare, AI is not a hype. It's needed to create this situational awareness picture that we actually need. Okay. This is more on a higher Saab level. Adapting to the future of defense. AI has a transformative potential for defense industry. And we have to focus on creating solutions in-house together with partners. And now I have to mention Hopsworth, of course. Saab also has a partnership with Helsing.ai in Germany. And the fields that we are doing AI are, for instance, multi-domain distributed sensor systems and autonomy unmanned systems, electronic warfare, which is a field that I've been in for the last around 23 or 20 years, something like that. And for all this, of course, we need artificial intelligence. Here are the domains that we work with within Saab. We do a lot. It's quite impressive that with 25,000 employees, we can achieve such systems. We do sensor for all those systems, and we do everything. We build aircrafts. We build the mechanics, we produce the electronics, we design the RF modules, and we create the software and create AI and make all that work together. Not many companies can do all that. The most common question, the question I always get, what problem are you trying to solve? And I always feel like, okay, let's go back to square number one. Why do we need AI? When we try to, what we do, what electronic warfare is for us, we have sensors on the aircrafts to sense the radars that are trying to see us. And we need to identify what is this and where is it and how dangerous is it. And in the past, it was quite easy to do so. The radars kept themselves within a small frame, small limited frames, making small boxes. There are three different parameters on the axis, and it worked pretty well. Since the boxes are small, they never overlap. But for future radars are becoming more agile, so they spread in the parameter space. The boxes becomes larger, and it's difficult to see what is it. Difficult to identify, creating ambiguities. So we need to find other ways to identify what is it, looking into more details inside the signal, and then we can achieve better identification. And to do so, we need to do pattern recognition, and for that, machine learning is much, much better than rule-based coding. Okay, and this is in a looking at it from another perspective. And this is to classify how dangerous is the threat. And we can see that the parameters are spreading within the same limits, but the patterns are different, and we use machine learning to identify what is it. And this is very simple data. In the reality, it's much, much more complex, but I can't show that because it's secret. So let's keep it simple. And the next common question I get is, how do we get the data needed to train the models? Not possible. The customers won't give it to us. The customers are Swedish armed forces, for instance, or other countries' armed forces. And it's very, very classified information, so not even we can get it. Okay, so what do we do? In the past, a lot of time was spent on model development. Some time was spent on data annotations, and quite little time was spent on synthetic data generation. At present, we do less model development, more data annotation, and a little more on synthetic data. But what we see in the future, or that is actually now, a lot of time will be spent on synthetic data generation. And when we do that, we get annotated data automatically when we generate the data, and therefore we can train the models much quicker. Closing the loop, reducing the time of the loop, simply. And how do we do that? Well, this picture is not so good, but what we do is that we define what does the radar emitters look like, set up the parameters. And then we define the space on a map and saying, like, within this space, let's generate 100 threads. And within another space, put in other threads and so on, creating a very complex environment on the map. And then we define a flight path that we fly our aircraft through that. And then we push the generate button and generate all the radar pulses that would hit the aircraft if we flew through that environment. Then we get lots of data to train the model on. But that is not enough. We also need real data, some sort of measurements, so that we know that we are on the right way. And so, since we are Saab, we have our own aircraft. We can fly them around, measure, and we can get something like that. Quite difficult to get, quite difficult to understand. It takes a lot of time to analyze that. And to annotate it dot by dot would take too much time. So as I said, we will need AI models to sort the data and annotate lots of dots or data points at the same time. You see the yellow line there. You can see that those dots are probably belonging together. So if we click on one of them and then use an AI model to realize which dots around this belongs to this from the same source, good. Then we can highlight that, and then we tell the machine to let's annotate all those dots or data points to the same thread. And then we can use that to train models. Let's see if I forgot something. I think I got that. Okay, so where do we want to use AI for electronic warfare? We have defined this. How do we reach cognitive electronic warfare? And we have found out that let's start in the analytics tools that the customers are using. And in there, we define. In there, it's quite easy because it's not so time critical. So therefore, we can create a system that works. And that is in the pre and post mission analysis. And we can store all the data in a large database. And we can check whether, if we see something that we don't think we've seen before, we don't know whether we've seen it before or not, we can check in the whole database, have we ever seen this before? And what did we define it as then? And update the database. And when we have that working, we can move on to real-time analysis. And that is when we download the trained models on a real aircraft and use it in the real world. In there we have 3 steps. First we have it in one aircraft. But after that we realize that, okay, what if we want to take this to the next step? Let's have AI models in several aircrafts and make them communicate with each other. And then we can define an even better situational awareness. If aircraft number 2 already can get the message from aircraft number 1, don't fly here, it seems to be dangerous, fly there instead, or something like that. And finally, we hope to reach some sort of cognitive level, which is quite hard to define right now, what it actually is. But as I see it, it includes self-learning during the flight so that we retrain the models as we receive new signals. And also apply jamming against the threats and evaluate the result of the jamming, so whether we can change the electronic warfare battle space or not. And here we have a simple example of what the very simplest model that we could think of. Let's say that we have a signal that looks like we have the frequency, a stepped ideal frequency emitter to the left. And we train a GMM, Gaussian mixture model, in accordance with that signal. Then we would get a GMM that looks like the signal described to the right. And after that, that GMM will recognize that kind of signal in the future. That will, of course, not be enough in the long run. We need much more complex model to be able to sort out more complex signals. And sorry, but I can't show you that. And I have this about edge. First, let's say something about this picture. 20 years ago, I wrote the software for such a system. This is a flare dispenser system, and it is a jettison function, and that means that you fire all the flares that you have at the same time, and that you only do that if it's kind of a crisis. The aircraft has to drop everything at the same time because otherwise we will crash. But the program that I wrote was more like, let's throw those flares out in such a way that we get the highest chance of defeating the threat. It's like if you're hunted by a missile, that worm-seeking missile, or what do you call it? Exactly, thank you. If you fire a flare, and it will go for that instead of the aircraft. So I optimized the routine for that. A quite cool thing, actually. I did it for a helicopter, though. I didn't do it for that aircraft. This is 2.0. I did 1.0. Then we come to this, what we also want to do in the future. Multi-source data fusion to reach intent recognition. Performing radar warner function is good, but what if we can combine the measured signals from several sensors into one situational awareness picture? Then we can achieve an even better picture. And that can be done like this. Let's say that you have passive sensors, you have active sensors, you have satellite pictures, and some open source data. And you feed all those into a massive data fusion service. And then after that, you can select information, select portion of the geographic position. And on the height, you have the time. So then you can follow something like a harbor to check what vessels have been in this harbor. And in theory, you could even follow a vessel, how it travels over the world, and build knowledge about how are things moving, and learn about that and sometimes we find something that is not so good. And this is a sort of a description of how to do the fusion. Different sensors, you have different sensors at different times, and combine them together as good as you can. Sometimes, well, when your aircraft is not flying, it can't measure, and then you don't have it. And when you have it, you use it to build a better situation awareness. Okay. So why am I interested in HopsWorks? How does this fit in? I would say it is not so smart to do everything by yourself. If you ever think about building a platform, then don't. I heard yesterday. Sorry, Jim. But we are Saab. We are used to doing everything ourselves. So this is kind of an exception that we have a collaboration with the platform provider, which I'm very happy with, that we can, since we can always go here to Södermalm and meet you and get input on how to use your platform. This is a picture I drew quite a long time ago. But what we want to do at Saab is the top of this pyramid. That's the AI functions that we want to achieve. But to be honest, the rest I don't want to do. I just want it to work. I think HopsWorks provides something in the middle of that. And since you provide that, then we can move on with what we are good at. We're not good at creating this pyramid anyway. And as for Swedish industry companies overall, it would be great if we can collaborate around this. Instead of everyone building their own pyramid, everyone should be building their own top of the pyramid, I think. But what are the functions we actually need from the pyramid then? From HopsWorks. I wrote something quickly here, like when I came here. And this is what I think that we need. We need, and you also talked about data lineage, for instance. We need the ability to trace a single data packet. That could be a radar pulse, radar track, a mode and emitter, a weapon system platform, whatever. We need to be able to track it, to trace it to its data sets. And which models were trained on this data, and from which recording did it come. And we need to prevent leakage from training data to evaluation data sets. We need the data annotations to be stored and traceable, updatable, version controlled. And I hope HopsWorks helps us with that. But we are getting started with this now. It's going to be very exciting to see how far you can take us. You look confident. I like that. And we need our models. We need to be able to have model version control, including back pointers to dataset collection, annotation collection, clean and transform script, training scripts, including hyper configuration. I don't know what I wrote, sorry. We need to orchestrate training, orchestrate test, orchestrate deployment in pipelines, security and access control. And we need the ability to collaborate within the teams around this, which is quite difficult if you don't have a data platform. So that's what I think right now that we need HopsWorks for a start. I hope I have got it. I hope we have a match.
It's a subset.
It's a sub. Yes, I know. You can deliver much, much more, but we need to start somewhere. So I think that was what I intended to say. So thank you for listening.